Hello everyone, it's August the 5th. Alright, I'm gonna put whatever yesterday behind. I don't want to think about it anymore. Don't want to deal with it anymore. And we just, move on from that one. Doesn't matter. What's the next one? My god. That's JavaScript. That's JavaScript. What's there so much JavaScript? Okay, so we'll start with this. But actually, from now on, I'm trying to get back to Java. So if it's an easy problem, I think I'm just gonna go with Java. We'll just go with Java. Just, to practice. But if it's a difficult one, so I will stick with Python because, don't have to strain myself to figure out how the implementation goes. Number of music playlists. Your music player contains n different songs. You want to listen to Go songs, not necessarily different, so they can repeat. During your trip, to avoid boredom, you'll create a playlist so that every song is played at least once. A song can only be played again only if k other songs have been played. Give n Go character the number of possible playlists you can create. That is very interesting. So first one, so we have n equals 3, so total songs, right? And then Go is 3. That's the number of songs in the playlist. And k equal to 1, number of other songs before a song can be repeated. Right? So it looks to me it's going to be a DP with n, Go, and k, right? So maybe we can say DP. Well, n, n, what's n? N is the total number of songs, right? So we can pick some song in it, right? Some song. N is the total number of songs. Go, so we can say the number of songs currently in the list, right? Number of songs in the list. And how do we DP this? N is just the total number of songs, right? N is the total number of songs. And Go is you want to fill. So you can say remaining, right? Num remain. So remaining, definitely. The number of songs remain to fill. But you kind of need to know what songs have already been there. Nah, it doesn't feel like DP. Okay. But anyway, so we have n equals to 3. So let's say I have 1, 2, 3. These are 3 songs. If I pick one, right? If I pick one, then we're saying we have 2 songs left, and we have 2 choices. Right? So I mean, if we think about it, to the start, we have always n choose Go. This will always work, right? N choose Go. That's the total number, none repeating, right? This is a none repeating. So in this one, it's not, because you can also change the order. So it's n permutate. Okay, n permutate Go. That's what it is. So this is going to be 3 permutate. Is that 3 permutate 3? Yeah, that's 3 permutate 3. That's 6. right? 3 permutate 3. How'd you calculate this? I forgot. I think it's I think it's n this divided by I don't remember. Sorry, I forgot. Permutation formula. I forgot. Permutation, what is the permutation? N minus R. So N, and then N minus go. Alright, yeah, that's right. So in this question is just gonna be 3 factorial and then 0 factorial equal to 6. That's the first one, right? So this second one, if we go N permutation, so that would be 3 factorial divided by 3 minus 2 factorial. No, it's 2 factorial, my bad. Oh, the goal can be bigger. The goal can be bigger. Oh, this is, hold on. So 3, I can do 3 factorial, right? Because go is 3, so n should be bigger than go. If n is bigger than go, then a song can only be played again only if k other songs have been played. And every song is at least played, every song is at least played once. So if n is equal to go, then there's just permutation. End of the story. Doesn't really matter how the k goes. Right? Doesn't really matter how the k goes. It's always going to be permutation. We can actually try this just to make sure. Alright? We can return mod is going to be 10, 9, plus 7. I just want to confirm, right? So it's going to be math.perm n go n minus, wait, hold a second. N, go is always going to be, yeah, then we can just say factorial n and mod, right? We can actually try, let's say 50 and 50. Doesn't matter you choose what. I think this will be right. If n is equal to go, yes. If n is equal to go, that's just factorial. Done. That's the trivial case. So now, when n is smaller than go, right? N is smaller than go, then some songs can be repeated, right? Some songs can be repeated. Okay, n is smaller than go, then at least among the go, like say this, we have 3 songs, right? Then if every song has to be played, then it's definitely 3 permutation 2. Wait, hold on. No. We have 3 spots, I only have 2. So it's going to be 2 factorial, right? There's 1, 2. So it's going to be 1, 2, or 2, 1. And then you can choose to where to put them, right? You can choose where to put them. And that's, we have 3 chooses 2 positions to put them, right? Basically, we're saying we can put, so we have 3, right? So we can put, so first of all, 1, 2. So we have 1, 2, 1, 2, and 1, 2, right? That's one way to put 1, 2. Or we can do 2, 1, 2, 1, and 2, 1. So yeah, we have 6. And this one says k equals to 0, so we can repeat however we want. So we can put a 1 or a 2, a 1 or a 2. Oh, shoot. If we do a 1 and a 2, 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 1 and a 2. So if we do 1 and a 2, so then we have 1, 2, 1 will overlap. So maybe we'll divide by 2, right? We divide by 2. But then the question is this, right? This. How are we gonna do when k has some value? So this k equal to 1 means a song can only be played again only if k other songs have been played. So n equal to 2, that means we have one other song, which means if you want to repeat, must have a song can repeat only if k other songs have been played. So this one's 1. We have one other song that has been played. Yeah. So basically, if my song is 1, then I must have 2 played already before I can play. Right? So in this case, so basically it means if I play, if I haven't been played, and that's the first time I play, so that's out of the consideration. So basically, we want the song itself and then k other songs that have been played. Right? So in this case, because I only have 2, that means 1, 2 must be played already before another song can play. So in the case of 1, 2, we can only do 1, 2, 1. In the case of 2, 1, we can do 2, 1, 2. But that's it, because 1, 2 has to be played already. Right? 1, 2 has to be played already, which means if there's something in a gap, then we cannot play any songs in there. Right? So like say if I play I play 2, 1, right? 1, 2, and 2, 1. I'm trying to figure this out. 1, 2, or 2, 1. You can put them in different places. And when you put them in the different places, then this will be difficult to do. Right? This will be difficult to do. So if you put them in different places, or you just put them at the start. I have 1, 2, and then you say, okay, then the third position I have 2 different options, right? I can do 1, I can do 2, and this is the same. I can do 1, I can do 2, but that's only 4. So I still think we have to lay them out, all possibilities, right? There's all possibilities. We lay them out, and just to see how k equals 1. How do we do it? Like in this case, right? K equals 1, so it has to be 1 other. So plus u, basically 2 other, and then total is n equal to 2, which means both has to be played, right? Both has to be played before you can repeat, and you have to repeat, right? You have to repeat. So if 2 has to be played, and then you have to repeat, so the only possibility is 1, 2, and 2, 1. Hold on. So what if my goal is big, right? Yeah, I mean, you can always, like if I have a lot of positions I can fill that only have 2 values, then we have a lot of different orientations of them, right? Which means, yeah, what if n equals to 5? Yeah, I'm curious. I mean, this is gonna be wrong, but I have to try it. What if n equal to 2 and go equal to 5, and then we say 1? What's the answer? Answer is still 2. Huh? Because you can only repeat after 2 is done. So you have to do 1, 2. Then you say, okay, then you can start repeating. Which means once you do 1, 2, this will be the same as n equal to 2, go equal to 3, and then k equal to 1. But this has 2. Because here you cannot repeat 2. No, you can. You can repeat 2. But 1, 2, 2 is not part of this. Hold on. Let me read this again. Unplay if k other songs have been played. One other song has to be played. Why 1, 2, 2 is not right? I wasn't thinking of 1, 2, 2. Hold on. In different songs, you want to listen to Go songs. To avoid boredom, you will create a playlist so that every song is played at least once. 1, 2. A song can only be played again only if k other songs have been played. Yeah? Why 1, 2, 2 is not right? That's a good question. Why 1, 2, 2 is not correct? You said, right? I play 1, I play 2, so 1 has been played, 2 has been played. Why I cannot play 2? A song can only be played again only if one other songs have been played. I have one other song been played. It didn't say that you cannot play the same song like back to back. You want to listen to Go songs. Not necessarily different. To avoid boredom, you will create a playlist so that every song is played at least once. Yes, a song can only be played again only if k other songs have been played. I think it means you can play a certain song. You can play song, let's say S, if k other songs. So if k other songs has been played. But this, we don't have k other songs has been played because I think I know what it means. That means if you play a song and then to play the song again, there has to be k other songs in between. That's what it means. Right? That's what it means. So, if you're talking about this, well, k equal to 0, I think that's a trivial case. K equal to 0, we can just use the other method that we use, right? So, if I say it's, 20, 50, okay, and then k equal to 0, my idea is going to be 20, right, factorial, times math dot factorial and permute combination. I have a combination, right? N to k, yeah, n choose k. So combination, go choose n. Right, go choose n. Let's see if this is right. Hold on. That might not be right, actually. Basically, you're just saying that we do... Yeah, let's just do like, let's say 3, 5, okay, 3, 5, right? 3, 5, 1, 1, 2, 3, I have 5, 2, 3, 4, 5. First, 1, 2, 3, I can permute them, right? And for each permutation, I have 5 choose 3 number of different ways to put them. So let's say we have some put in this way, and the remaining values, right? Remaining values, so we can say that can be all different types, because this one I can fill all 3 of them, right? I can fill all 3 of them, so that's actually 3 to the squared, right? 3 to the squared. So this should times go minus n times how many, and then what? And then you need to probably divide it by 2. I'm not sure if it is divided by 2, because when you do whatever, you are overlapping with the other situation where, yeah, because all those has happened. I don't know how many times it has happened, right? How many times it has happened. So maybe let's do let's not do 5, let's do 4. I want to investigate, right? If we do 4, okay, if we do 4, right? If we do 4, then I have, 1 to 4. You might want to write them out. 1, 2, 3. Right, 1, 2, 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. Right? And then 1. Oh, that's a lot of them. There's 6 of them, right? Then we have 1, 2, 3. And then we're going to do 2 at first. 2. That's it. That's all of them. And then we have 2, 1, 3, all these, and 2 something, all of these. And now each place position I can do, like this can be 1, this can be 2, this can be 3. If it's 1, then I have a 2, 3, 1 that I can hit, right? Yeah, I have a 2, 3, 1 that can hit, a 2, 3, 2 that can hit, a 2, 3, 3 that can hit. So, I seem to be a lot more situation than I had expected. Maybe that's not the right way to think. Because by itself, it's going to be 3 factorial times 4 choose 3. And I think 4 choose 3 is equal to 4 choose 1 is equal to 4. So this is 6 times 4. But in this case, okay, each one can times 3. But then I need to divide it by something. So, not sure. I might just do whatever and just see. This is 72. Is it 36? So it is. So what this one is divided by 2, right? It is divided by 2. Because you're saying that because there's only 1, that's different. So we say divided by 2. But if I go, this one becomes 5, right? Then again, it's 3 factorial times 5 choose 3. Now 5 choose 3 is very different. 5 choose 3, what's 5 choose 3? Yes, 10. 5 choose 3 is 10. right? But then you're faced with the thing is you have 1, 2, 3, you have 2 positions. Each can do 1, 2, 3. Each can do 1, 2, 3, right? Now you pick one, you can pick another one. You pick one, you can pick 2. Pick one, you can pick 3. So that's, I call it 3 times 3. But then we might duplicate again. But that could have more duplication than we'd expect, right? Like how many duplicates can we get? Because if it's a 1, then we are duplicating with 2, 3, 1. Right, in here, if I choose 1 and 1, then we're duplicating with 2, 3, 1, we're duplicating with 2, 3, 1. Right? We're duplicating, but if it's 1 and 2, I have this duplicating. Right? I duplicate with this. Because I can be 1, 2, 3. I can be 1, 3, 2. I can be 1. I can be this 1, 3, 2, 3. Oh, that's way more complicated. Way more complicated. So I think this is way more complicated. I don't know. I don't even know what this one is. If we do 3 and 5. Yeah. You know what? I don't think this is the right way to think. Let's rethink this problem. Let's do 2, 3, okay? N equal to 2, go equal to 3, and k equal to 1. In this case, we have 3 positions, 2 values, right? And then k equal to 1, which means there has to be at least 1 different in between the repeats, and we have to have repeats. We have to have repeats because n equals to 2. We have to have repeats. So I can say, okay, what if I want 1 to repeat? If I want 1 to repeat, and if I set 1 at the beginning, then this position cannot be 1. So this position be 1. Right? Then this has to be 2. That's it. Bless you. And that's all if 1 at the start. Right? Now we can say 2 at the start. So we have 2 at here. So the only one is this is 1. That's it. That's why there's only 2. Okay, now let's try n equal to 3, g equal to 4, k equal to 1. Okay? So if we want to do this, we have 4 position, 2, 3, 4. Right? If I do 1 here, because 1, 2, 3 has to be in there no matter what. And this tells us we have 1 repeat. So we can choose, right? I can choose 1 to be repeat. So if 1 is repeat, 1 can be here, right? Or 1 can be here. These are the 2 situations that 1 can repeat itself. And once we choose 1, then we have 2 other values. And we can do however we want. So that's actually 2 factorial, right? This is 2 factorial. And then for the other situation is the same. So this shall be 2 factorial times 2 times 3, right? So that's equal to 2 times 2 times 3. It's 12. Is that 12? No! That ain't right. Oh, now times 4. Because 1... No, it is. It is. Times 3. Because it can be 1, it can be 2, it can be 3. If it's 1, I have 2, basically 2, 3, 3, 2. Right? 2, 3, 3, 2. So 1, 2, 3, 4. Hey! Why do I have 36 different? Let's see. That's 1 is the first position. Oh, 1 probably can't. That's it. 1. That's the only number of 1 that can be, right? Then we can do 2 at the start, and the other 2 is here. 2 at the start, the other 2 is here. And 3 at the start, and 3 at the start. And you cannot do another. I cannot do another 2, and I have to have 1, 3. So what else are we talking about? 3, 4. We have 36. What? Right? If we have 1, 2, 3, we can do a 1. Oh, we can do a 2. Oh God, that is correct. Oh, we can choose others. So when 1 is in the start. Oh.
Have you seen a red mouse?
Yes, I think it should be on top of the cat tree. One of the cat tree. Yeah, we forgot this. Yeah, for 1, that is true. But that's not all when start with 1. Right? So we can say we start with 1. I can repeat. If I want to repeat 1, yeah, that's it. But I start with 1, I can also say I want to repeat 2. Right? If I start with 1, and I say I want to repeat it to be 2, then that means repeat 2. Right? That means I don't have 1 again. Then that's a problem of 2, 3 fit into 3 situations. So that means n equal to 2, go equal to 3, and k equal to 1. And we solved that already. And that is a 2. Right? That is a 2. Oh no.
What he likes?
Maybe we can buy that toy so he had to fish something out.
Oh, yeah. Let me get it out.
Yeah, get it out for now. It's alright. He hasn't had a mouse for a while. He's definitely gonna go crazy on it. Alright, where are we again? So, okay. If I don't do 1, right? And then that's a 2, 3. That's a 2 value. N equal to 2, go equal to 3. So we solved this problem already. That's a 2, right? We have 2 different ways. If we want 1, so that's basically 2 factorial plus 2 factorial plus another 2. And that's 2 plus 2, 4 plus 2 is 6, right? But 6 times 3 is 18. We're still short. We're still short. We are still short. Gosh, we're still short. What else? What else? Let me see. Did we miss any more? Yeah, if it's 1, 2, 3, that's gotta be a 1 or gotta be a 2, and that's it. Can't do any more. Don't worry, I didn't play together. Yeah. right? We have a 2, 3, we have a 3, 2. And for 2, 6, and for 3, we have 6, 6, 6, 6. And we have to double it. Think about it. If we do 1 at the start, right? If we say first is 1, and then we have 3, then I have 6 different things. That is bonkers. Oh, it's a 0. Oh, my bad. It should be 1. I was still dealing with a different 18. That's 18. It's interesting, right? It's 18. Okay, so this analysis is right. Which means, can we do n equal to 3, go equal to 4, k equal to 0. Then we say 1 at the start. Okay, now we have 3 position to fill. Then I can fill however we want, right? However we want. And however we want to fill. Yeah, because k equal to 0. Then I can do basically that's 3, so it's gonna be 3 factorial. You need help? You need help?
I don't see it.
That's okay.
So many colors.
I just get a new one then. Let's give the new. All right, back at it.
Where you put it?
Right there.
That's the one I just put back.
Oh, that's the one you put back? All right, how about this one? All right, let's see. So I can do, the first is 1, and then is 3 factorial. First is 2, and then 3 factorial. So it'd be 3 factorial times 3. Isn't that 18 as well? We know that's not right. We know that is not right because we have to have 1, 2, 3. Hold on. Hold on. That's not the way to think. We shall use this k to think. So if we use k to think, then we want repeat to be 1. So we either have repeat as 1, repeat as not 1, right? So if repeat is 1, then we can do this, we can do this, we can do this. Each one is 2 factorial. So we have 2 factorial times 3. Second situation, we don't want 1 to repeat, so it's going to be 2 repeat. So now we have n equal to 2, go equal to 3, and then k equal to 0. Okay? So 230 give us 6, right? 230 give us 6. So that means we have plus 6. And this times 3. So that basically is 6 plus 6 times 3. That's 32, or 36. That is correct, right? That is correct. Okay. So now let's do more complicated. Is this the one more complicated? 150, right? Now that's 42. Which one is more complicated? Is it 4 or 5? I remember one of them is 150. 144. I mean, these are all fine because I can do dp. Now I see the dp in it, right? Now I see the dp in it. How about we do, let's say 3. I mean, it's fine. Basically, just you secure the first position, right? However many we have, then based on the k, right? Based on k. If k is 0, then you start from here. If k is larger than 0, k is 1, you start from here. If k is 2, you start from here, right? Every time you set it, then the remaining is just going to be permutation, right? The remaining is just going to be permutation. But I think 351 is a good one to try. So n equal to 3, go is 5, and then k equal to 1. So we can have this. Oh, then the problem is transformed into n equal to 2, g equal to 4, and then k equal to 1. We can transform. So how do we solve 2, 4, 1? Doesn't matter which one. It can say 2, 4, 1 have 4 positions. So 1 is here, and k equals 1, so 1 will be here. And then in this order, of course, 1 is here, and 1 is here. And then, now this question is transformed into n equal to 1, g equal to 2, right? That's actually 1, 2, 3, 4, 5, 6. My bad. It's actually 6 transformed to 5. I think I might have it. I might have it transformed to 5. But you know what? Let's not do that. Let's not do transform to 5. Let's just keep with it. Be 5. We delete this one, right? And then it's transformed to 4. No, 3. Oh, because I got 2. I got 2 in. Dang it. Dang it, dang it. Yeah, it's 5. 1, 2, 3, 4, 5. 6. 6. 6. Take 2, now become 4, right? And then we use 1, so we have 2 left. So 2, 4, k equal to 1. And then we take 1 here, then it can be 1, g equal to 2. Then this is always going to be 1. Oh. Not necessarily, because I cannot do 2 and 2. Dang it! That's... that's not straightforward. I think we have to handle the case when n equal to 2, right? When n is equal to 2, we have to handle it, maybe manually, because we can't really get n equal to 1, because n equal to 1, right? N equal to 1, and we have k equal to, only k equal to 0 work. K equal to 1, it doesn't work, right? So in this case, we can do this, but we cannot do this. So if n equal to 2, n equal to 2, g equal to 4. So we can say, okay, I set 1 here, and then we have to repeat. Then we have to have 1 here, or we have to have 1 here, right? And then, depending on so n equal to 2, k equal to 2. Is that not possible? Yeah, if n and k is the same, then it's not possible because I have this. K says I have to play at least. Yeah, so I want to play me again, so at least I need to have 2 different. But I only have 2. So that means if I have these 2 are the same. Oh, k has to smaller. K has to be smaller than n. So this will not happen. This will not happen. So this will not happen. K has to be smaller. Okay. So k is smaller and n is equal to 2. So n equal to 2, k has to be equal to 1. Alright? And what if go equal to 4? Exactly. That's a good test case. K equal to 2, go is 4. N equal to 2, go is 4, and then k equal to 1. So what I'm saying is whenever you have n equal to 2, you probably have to do it manually. Because I can say, and it start with 1, alright? I say I want 1 to repeat. Then 1 has to be in this position, or 1 can be in this position. But we also know that when n is equal to 2, and if k is not equal to 0, when k is not equal to 0, and k equal to 1, that basically means we cannot leave consecutives, right? We cannot leave consecutives. How do I rationalize this? So I think this should be 2, right? This should be 2. I just pressed submit. Jeez, man. I'm trying to run this code. Yeah, that's 2. Yeah, it's the only one. So we need to know. What do we need to know? When the distance between the two gets too big, then it's not possible, right? Then it's not possible. So this is possible. How do I say this? Because I only have 2, right? And I think when n equal to 2, k equals 1, this is going to be 2. When n is equal to 2, k is equal to 0. And regardless of g, right? This is regardless of g. Doesn't really matter. Your g can be as big as you want, right? Your g can be as big as you want. That is still going to be 2. because there's only one way to handle. Yeah. Now, the k equal to 0, that's a different situation. Whenever k is equal to 0, yeah, that's a different situation. If k is equal to 0, right? If n equal to 2, g equal to 4, and k equal to 0, then we can say we have a 1, next one can be here, next one can be here, next one can be here. So it's basically 3 situations. Each situation has, we can do whatever you want. Because we saying that's, oh, that's what we repeat? Now you can have more repeats. Oh, yeah, now you have more repeats. Because go is 4, right? Then you can have more repeats. I think you only solved if we have 1 repeat. Yeah, I think only solved one have 1 repeat. Okay, let's try this. N equal to 2, go equal to 4, k equal to 0, right? 3, 4. And I need repeats. If I do 1 here, oh, but k equal to 0, that's different, right? If k equal to 0, that means this problem is transformed into n equal to 2, g equal to 3, k equal to 0, because I can do whatever I want, right? If n equal to 2, g equals to maybe 3, then I can do 1 here. Then we transform this problem into n equal to 2, g equal to 2, k equal to 0. And we know when n and g is equal, and then k is equal to 0, actually it doesn't really matter. As long as n and g are equal, we don't really care. We do care. We do care. Because when n and g is equal and k equal to 0, that means we can do, no, we have to play every song. We have to play every song. Yeah, that's fine. This is fine. If these two are equal, because we have to play every single song. So that's 2 factorial. That's no question. But this, n equal to 2, g equal to 3. So we do 1. And the remaining can be whatever. We have to be 2 factorial. We have to be this, right? Because, yeah, that's fine. We pick 1, and then we need to do all the others. But it doesn't have to be all the others, right? It doesn't have to be, because I can do 1, 2, 2. That one works as well. 1, 2, 2 works as well. Didn't we solve this already? N equal to 2, go equal to 3? Because the first situation is we only do, oh yeah. So the situation is, oh, hold on. 2, 3, the situation is we know that we're gonna have repeats. we're gonna have 1 repeats. Okay, I remember, that's how we solve this. We're gonna have repeats, right? 2, 3 is, we're gonna have 1 repeat. So it's guaranteed. We have 1 repeats. So we can say on repeat 1, so it has to be here. Or we can have 1 is here, right? And for each repeat, this is gonna be n equal to 1, because I don't do 1 anymore. So n equal to 1 and g equal to 1, right? So there's 1. So I have 2, right? We have 2. So, and also we can say I don't want 1 repeat. I want the others. So that's going to be n equal to 1, g equal to 2. And if n equal to 1, g equal to 2, and k equal to 0. Right? Then if that is the case, then this is going to be just 1. So we have 3 scenarios for this. 3. For 1 start. And I'll have 3 for 2 starts. So in total we have 6. Right, we have 6. So for 1 at the start, if I do whatever, it's going to be 6. Is that all of them? I don't really think so. I don't think it's exhaustive. Hold on, let me think again. 1, g equal to 4, right? So we have 2 can be repeats. We have 2 repeats. I can be or 1, or 1, 1, or no 1. I think this is, it includes both. Let's actually make it harder. Right, I have 2 repeats. So, and k equal to 0. So let's just do 1 repeat. Okay, let's just do 1 repeat first. I want 1 to have 1 repeat, and then that's it. So I can have 1 repeat is here, or 1 repeat is here, or 1 repeat is here, right? And in this case, we transform into n equal to 1, g equal to 2, and k equal to 0. Right? N equal to 1, g equal to 2. And whenever n is equal to 1, the answer is only 1. So this has 1. And this has 1. And this has 1. So we have 3. And then 2, and that's only, right, that's only 1 repeated twice. And if I want 1 to repeat 1 more time, for another time. So now basically we have 3, we can pick 2. So we can do 1, 1, right? 1, 1, or 1, 1. And each one, the remaining n is also equal to 1. So that's also 1, 1, 1. And last we can say, I don't want 1 to repeat. Then this is only 1. So 1, 2, 3, 4, 5, 6, 7 times 2 shall be 14. Right, so g equal to 4, k equal to 0. This one shall be 14. Yes, that is 14. Okay, let's keep going. So what if n equal to 2, g equal to 4, and k equal to 1? How would you do that? K equal to 1. Well, if k equal to 1, again, 1, 2, 3, 4, I can say I want to do 1. Again, I have 2 repeats, right? But k equal to 1, so I can only do 1 here, or 1 here, right? Then for 1 here, I have remaining is going to be n equal to 1, g equal to 2, and k equal to 1. Yeah, that's when it's kind of get tricky, right? That's when it gets tricky, because that is not possible, because n and k cannot be the same. Which means I think when n and k is different only by 1, we have to consider it separately. When they're different by 1, then that's the only one. This one doesn't work, right? So this is actually equal to 2. What if we have n equal to 3? I don't know, g equal to 5, but k equal to 2. K equal to 2, right? Which means if I have a 1, and I know I need to repeat, if I want to repeat 1, then I have to get 2, then I repeat 1. And then these 2, right? 1, 2, 3, 4, 5. And I cannot do this, right? Because if I repeat here, and I say inside, that's gonna be, we're reducing it to an equal to, so, which means there should be no repeating. We cannot repeat. What do you mean by we cannot repeat? It's not like we cannot repeat. It's if we have 3, right? And then we have n equal to 2 and then k equal to 2. That's not possible. So whenever this, that just means, oh yeah, I know. When n and k is different by 1, so the only way is, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's the only way, right? That's the only way. Which means when they're different by 1, one has to leave all these positions, and then we get another 1, and that's the only one. And here we have 2, so that could be 2 factorial here. And the last one can be, the last one can be, and that's only 1 repeated once, right? Still, 1 repeated once, and then remaining will have 3 spot. I have 3 spot. I have 3 spot to fill. Then these 2 spots is determined, and then this spot. But what if you have, like a lot of repeat? I think I still haven't quite get it yet. No, I don't think so. I don't think you have gotten it yet. If I have a lot of repeat, so you cannot analyze every situation by itself, right? Yeah, what if you have like, this one you can already say, one I have, this one it's easy because that's the only repeat you can have. And now the thing in between has to be 2. Alright, and then k equal to 2. Not possible, so this is just going to be 2 factorial in here. And this is a 2 factorial, and whatever here, yeah, if it is 2, 3, then it can only be 2. It cannot be 3. Oh, because k equal to 2. I don't know, this doesn't feel very doesn't feel very exhaustive, honestly. Can we? I don't know. If because we need 3, right? So 1, 2, 3, 4, 5. If I set 1 is the first, right? Then the second position, right? The second position I can say I cannot be 1, right? So the second position can be 2. Or the second position can be 3. Now when the second position is 2, the third position cannot be 1, cannot be 2, can only be 3. Right? And about the fourth position. Fourth position, I have choices. I can do a 1. Only do 1. I can only do 1. And the last position, I cannot do 1, I cannot do 2, I can only do 3. No, I cannot do 1, I cannot do 3, I can only do 2. So that's 1. And which means we're actually dealing with n equal to 2. It's not n equal to 2, n is equal to 3. Right? N is equal to 3. I just pick 2. Right? But this doesn't really matter which one you pick. You pick 2, however many you have. You can pick 3, however many you have. It doesn't really matter. It does not. Because these are the unique ones you're taking away. So basically just say I take 2 uniques, right? I take this, I take a different one, then I have whatever uniques given the previous 2 situations. What are the ones? And the third one, so in this second position we actually have 2 choices, right? And this we only have 1 choice. And this we have 1 choice, because this we cannot choose this, right? We cannot choose this, so the only ones I can choose is the first one. And the first one only have 1 choice, it's only have 1. And this I cannot choose this, I can only choose exactly as this, whatever this is. Right? So that's only 1 choice. So from 1 start, that's only can give me 2. So this is 6. You gotta be kidding me. No, you're not doing 2 for 1. You're doing 3, 5, 2. 3, 5, 2. It's not 2 for 1. You're doing 3, 5, 2. 6. Yes. So what is this analysis? This is analysis basically saying, can we do another one? Can we do a 4, 5, 2? Okay, that seems to be interesting. 4, 5. Okay, equals to 2. So I can do first as 1, which we have 4 choices. Second position, because k equal to 2, so I cannot choose 1. So I can have 3 choices here. The third one, right? The third one, I have no repeat yet. Cannot repeat. So this I have 2 choices. The fourth one. Now the fourth one I have choices. The fourth one I can choose because the fourth one I have I can choose different from the previous 3. Right? Because previous 3 basically get basically the previous, so I can choose 4, or I can choose one. So I have two choices here, right? This position I actually have two choices because I can choose this or I can choose to repeat. And the last position, I cannot repeat this, I cannot repeat this, I cannot repeat this. So I can only repeat, the only option is to repeat this, which I only have one position. It's only one choice. So which means this comes up to 1 times 2 times 2 times 3 times 4. What's this? This is 48. That's not right. Right? That's not right. That's not right. $72 goes 4 times 18. 18 is 3 times 6. So this shall be 6. Which means the last one shall have 2 options. If I have 1, 2, 3, okay, if I 1, 2, 3, 2 more, I can do 1, which I repeat. For the last one, I can do 4. Or I can do 2. Yeah, it is 2 options. If I do 4, right, 1, 2, 3, 4, then here I can do any of these 2. So no matter which one I pick, this is 2 options. Ooh, hold a second. So no matter which one we end here, we can always go 2 back and pick the number of unique in here. So this, I only have 1 for the repeat, and then 1 remaining, so I have 2 options. For this, I can go to these 2, so I have 2 options. So I can do whichever. Well, I mean, it depends, right? It depends. If I get a new one, then this will do one of these. If this one already get this one, then I cannot get this. Then I'll get the remaining one. Because in this, yeah, it's Can you do 451? Yeah. 4 options. 1, 2, 3, 4, 5. Second, cannot repeat yet, so now we have 3 options. The third, okay, the third I can do 1 because I can repeat, or I can do 3, or I can do 4. So this has 3 options. And the fourth position I can have, if this is 1, right, then I can have I can repeat, but I cannot repeat this one, or I can do 3, 4. If it's 3, then I can do, I can repeat any one of these 2. I can repeat 1, 2, or I can do 4. If it's 4, I can repeat again 1, 2, but 3. So this is actually 1, 2, 3, 1, 2, 3, 1, 2, 3. This actually we have 9 different options here. Actually, no. Each one has 3, right? Each one has 3 options. This is also 3 times. Each one has 3 options. But the last one. The last one, if I go 2, right? Again, I can repeat. If I repeat, yeah, whichever value I end up here, I can always repeat. Yeah, I can always repeat. Hold on. So up until here, I have however many options that I have. Right? What if I know n equal to 4, g equal to 4, and k equal to 1? I know this, right? Because this is just factorial. Oh, that's different. That's different. Because if you take 1 out, right, take 1 out. Because I want to consider 5, but 5 is complicated. What if I know 4? Right? So you can do this plus 1, get a new one. Basically, it's just 4 factorial. Right? I have 4 factorial. And you get the new one. That's just basically 4 factorial, right? 4 factorial, and then this is a new one. No. You are thinking wrong. You're thinking wrong. Because that is a repeat. Yeah, if I want to solve 451, right? If I want to solve 451, I can consider a 441, right? And then this has to be a repeat because I already used all 4, and this is going to be a repeat. What type of repeat? Well, as 1, so I can only get one of this, one of the 3, right? So basically for each one of these, I have 3 options. So it'll be times 3, right? Or I can say is n equal to 3, g equal to 4, k equal to 1. Right? So 4, I got 3 options. Right? I got 3 options. So in that case, just we do 3, 4, 1. Right? We do 3, 4, 1, and however many we get. And this can be, so I don't know what this is. What's 3, 4, 1? I forgot. I think I did 3, 4, 1 earlier. What's 3, 4, 1? 3, 4, 1. 18, right? So we say we have 18. And we can do all 18 of them, because this could be a new value, right? Could be a new value. Plus, or I can do a repeat. And I have how many repeats? I can have, different, we can have different repeats. $18 of them. Uh, 18 of them. N equal to 3. Yeah, we can say 1, 2, 3 to fill 4, and the last one we get 4. That makes sense, right? Or we can say 1, 2, 3, and the last one can be one of the values, any values that's at this position, or this position, or this position, right? It doesn't really matter how it is, as long as this and this is not the same, but this and this can be the same. And for each one of them, I can have 2. Now, for this, I also have 3 different. Is that 3 different? Not necessarily 3 different. Yeah, it might have also repeats. I don't like it. I don't like it. All possible with the previous, and then we try to figure out which one I can give for the last. That sounds a very nice idea. Right? That sounds a very nice idea. Gotta feed cat. Uh-oh. I'll be back. think I'm thinking the problem too complicated. I feel like it has a easier solution. Set some value at the front, okay? If you set some value at the front, and the second position, you should know how many you can pick. The second position, you know how many you can pick, right? And then the third position, you should also know how many you can pick. You're welcome. If the first position is determined, right? The problem is not turning into this. Well, if the first one does not repeat, then the problem does turn into. Right? If the first one doesn't repeat, the problem does turn into the remaining, just n minus 1. Yeah? It does turn into that. But then, if the first does repeat, but we know where the first can repeat. We know where they can repeat because of the k. We know where they can repeat. So once it starts repeating, right, then the remaining will also be. You know what? That might be the idea. That might be the idea. The first one is determined, right? If the first one is determined, then, yeah, let's go back to the idea of n equal to 4, g equal to 5, and then k equal to 1. If the first one is done, then we have 4 positions. We can say we don't want to repeat the first one again. So the problem does translate into n equal to 3, g equal to 4, k equal to 1. We have converted it. Right? Perfect, we converted it. If we want to repeat the first one, then we can repeat the first one at, the third, 0, 1, 2, 3, index 3. No, 0, 1, 2, index 2. We can put 1 here, right? We say 1 repeats here. Okay? If 1 repeats here, and because n equal to 4, g equal to 5, we only have 1 repeats. So we put it here, And the remaining is, yes, remaining is because whatever we do in the center there, it doesn't really matter. All right, it doesn't matter. We can do, yeah, we can do whatever because it's allowed to repeat. Okay. We can do one here. We do one more. Yeah, that's allowed. Until we have N and G are equal. Right? N and G are equal. Until N and G are equal is in between. I mean, this is fine, but what if you have multiple? You can repeat multiple times. N equal to 3, G equal to 5. If you can do it multiple times, N equal to 3. So you can say 1 is here, and then remaining you can do whatever you want to do. It doesn't really matter. Say 1 does not repeat. And then you can say 1 repeat once. And then you can do 1 repeat once. Or you can say 1 repeat twice. How do you handle 1 repeat twice? Well, you can say the first time has to be here. And the second time has to be here. Thank you. So you will know how many repeats there are, right? You know how many repeats there are. Yeah, that's the idea. We focus on one value, right? We know how many repeats there are. We focus on one value. So this we can do, right? 1, 2, 3, 4, 5. We set as 1. The problem convert into N equal to 3, G equal to 4, K equal to 1. And we can just write it like this. This one converts into 3, 4, 1. I can compute 3, 4, 1, right? Or I can say I want to repeat once. So 1 is here. Okay? If 1 is here, then here we have 2 choices. Right? Because there could be 2 and 3. We have 2, 1, 2, 3, 3 choices, my bad. There can be 3 choices. So whichever choice this one get, these two, well, because I have a 1 is here, which means this can pick, I can repeat this, whatever this is, so it doesn't really matter. So this translates into 3, 2, and 1. Now 3, 2, 1 is interesting. That is interesting. No, we cannot allow repeat. We cannot allow repeat because this is a different one. So no more repeats. No more repeats. No more repeats. Actually, this allow repeats. This is actually no more because I did repeat already. Right? So it's 3. So that's actually 3 factorial. That's it. 3 factorial. Or I can do, what if I put 1 here? If 1 is here, again, that's 3 factorial. And this is also 3 factorial. So in this case, I can say the answer is going to be this plus this plus this plus this. What's 3, 4, 1? 3, 4 is 18. So I think this one is 18 plus 3 factorial times 3. And then the first I can pick 4 different. Alright, so it's 18 plus, that's 6. That's 18. So 4 times this. 4 times 36. 144. That's 144. That's actually easy, right? That's an easy case. N equal to 4. 4, 5, 2. 4, 5, 2. 1, 2, 3, 4, 5. I pick 1. Again, I have 3, 4, and 2. We solve whatever 3, 4, 2 is. And what's 3, 4, 2? Actually, I don't know. 3, 4, 2. This is 6. Now allow repeat. 1 here. Oh, that's the same thing. Because there's... Ah, this one doesn't really matter. Oh, this we cannot do it here. Dude. 1 has to be here. So that's actually 6 plus 2 times 3 factorial times 4. 4 times 6 plus 2 plus... Right? 4 times 18. That's 72. Hold on. I'll be back. I'm looking for my glasses. Okay, let's try 351. Again, we can translate it to 251. What's 251? Isn't that just 2? Yeah, that is 2. I think 2, 1 is always going to be 2. Okay, then what's that repeat? So I can repeat here, right? Then we have, that's it, right? A 3 spot, but we have 2 values. 3 spot for 2 values. 3 spot for 2 values. I think two values, 3 spot, 1. That should do, right? Because whichever value I pick here, now you can repeat. These two can repeat. Yeah, these two can repeat. Well, here I have two options. And here, because I don't really care about, because I already skipped one. So this, I can pick whichever. So it doesn't matter. So this is just going to be 2 factorial here. So that is going to be 8. No, that's going to be 4. What if 1 is here? And this has to be 2 factorial. That's it. And this has to pick one of this. Then I can pick whichever, right? Because I got this. So this, yeah, I can pick whichever. Which means I have 2 options here. So it means that's 4 as well. Because I can do 2, 3. That can be 3. I'll go 2. Alright, so that's 4. And I can now do one more because can I? Now we have 2. Oh yeah, this is 2, 3, 1. 2, 3, 1, I believe is also 2. So this is going to be 2 plus 4 plus 4 plus 2. That's 12. So it should be 3 times 12. That's 36. No. 42. 42 divided by 3 is 14. I'm missing 2. I'm missing 2. Oh, I can have 1 can repeat twice. Yeah, I forgot that. So the last one is going to be 1 repeat twice. There's 1 repeat once, and 1 can repeat twice. So I can repeat here, and then repeat here. Yeah, this is also only 2 left, so that's 2 factorial. Yep, so that's 14. That's gonna be 42. But how does this one scale? Yeah, how would you scale this? This one is easy. This we need to analyze. Right? We need to analyze. I kind of don't want to analyze. That's the thing. We don't want to analyze. after 49 is 352. A 252. Oh, and this is not possible. This is not possible. Then we have repeat. Repeat once. No. First repeat is not here. So first repeat is here. So when I repeat here, here can be whatever. So we have two left, right? We have 2 left. So here can be whatever. 2 factorial. But here has to fit. And this we cannot have another repeat. Yeah, we did this one before. So what if it's become big? Again, the first one, I can do that. And if it's not possible, I can say it's not possible. And then I can try to find repeats. So I find the first repeat. Once you find the first repeat, the remainder is going to be whatever. So we can do that. Now factorial, this is basically just this permutation, this, right? N minus 1. Whatever this gap, whatever this gap is, the gap permutation, N minus 1. And once we're done, how about, what if we have giant remaining here? Right? What we're gonna do with this giant remaining? Yeah, that's a good question. What do we do? Because this position can take this, but it cannot take this. It can only take this. It cannot take this. What if I take this? So given whatever this one is, 2 factorial, doesn't matter, we have some combinations. Then you start from here. You cannot say you cannot just say it's, whatever, right? You cannot say that. Yep. welcome. Let's see, what is it? Dynamic programming. I know it's DP, but how do I delegate the problem to DP? Yeah, this doesn't seem to work. No, because you do 2 factorial, you do 2, 3, and 3, 2. How about this last one? How do you reason it? Or what if we have many, many values, right? We have many, many values. Like we say this like 20, right? 20. If I have 20 values, yeah, you did get that. So what's the remaining going to be? And what do you delegate? I mean, for this position, if it's 2, 3, and this can take 2 or 3, right? No, this cannot take 3, because this is 3, so this can only take 2. Right? This can only take 2. This can only take 2. Oh yeah, this is the situation of 3, 2. Which is just locked in. It's just locked in. This is actually a special case. I think 3, 5, 2 is a special case. Yeah, I probably shouldn't use that. What about the other idea with if I have 4, I just need to add a 1. If I have all different, I think we thought about this, but it doesn't seem to work, because I can say, and go back to 451, right? I can say I can do a 3, 4, 1 here, and then I add a new one, right? And the new one can be the fourth one. We can add a fourth one, so basically it's doing this, right? Or yeah, that just means this is by itself. So it's actually exactly like this, right? Or this is, we're gonna do, no, that's 4, 4, 4, 1. No. 3, 4, 1. And we can pick any of the 3, and this will be the last. Okay, so this is like different from any. So we pick 3 values. All right, we pick 3 values, fill it, and this will be a different value. That works. Or we can pick 4 values here, 4, 4, 1, and this will pick a value to repeat. Right? We pick a value to repeat. That's another one. And because I can choose 3, so it will be 4 value, choose 3 value, times this, and this will be different, so plus this. What's 3, 4, 1? Three, 4, 1 is 18. So 4 times 18 plus what is 451? 144, right? And for each one has 3 different options. What's 4 factorial? It's 24. 144. Yeah, this is right. But I feel like 352. Say I need these 3 to be different. But that's not possible. Right? That's not possible. Because it's going to be 2. And the k is 2, so it's not possible. So that's not possible. So that means this has to be 3, 4, 2. If we do 3, 4, 2, right? If we do 3, 4, 2, and the last one, we go 2, so it would be 3, 4, 2 times 2. What else? What's 3, 4, 2? 3, 4, 2 is 6. So this will be 12. Is this 12? 3, 5, 2 is 3, 5, 2, 12? No, it's 6. Yeah, because I think maybe, I don't know. I mean, just 1, 2, 3, 1, right? One, 3, 2, 1. That's it. So here, yeah, I can only do 2 because you cannot do 1. See, that's the difficult part. The difficult part. You can say the first position. I can also say for this, right? Based on this, we know the first position that does allow repeat. If it is a 1, then the first allow repeat is here. This is the first one that allows repeat. So which means the first 2 can be whatever you want, right? And this we can repeat. So whatever this is, this can have more options. Doesn't feel right. It's been 2 hours. Still stuck. Or can we, get 3 and we have 4 position to insert another 2. Okay, with 4 position we insert another 2. So like, how do we insert the other 2? And it's required that the repeat can only be, we just insert 2, can be any position. So the total that we can insert is going to be 1, 2, 3, 4. 4 choose 2 positions, right? 4 choose 2. Now 4 choose 2 is a lot. Yeah, that's a 6. So basically we can have 6 different ways to choose, to put. And if we choose to put, and there'll be repeats. That's the thing. And we'll repeat. We'll have repetition. That's the worst part. It will be repetitions. It has to be DP, right? It has to be DP, but just how do I construct a DP? I can't even handle 352, but well, you can say 352 is an edge case. We don't have to worry. But we do have to worry, because whenever this differ by 1, it has to be only 2. You can say, okay, that's an edge case, but like what I say, let's do 5, 10, 3. How are you gonna do 5, 10, 3? Right? How are you gonna do that? You can say we set 1 and the remaining is all different. Fine. That's gonna be 4, 9, 3. Well, that's gonna be 2 different options. Now how about say 2? Right? Now it's be 4, 9, 2. Then you have to solve 4, 9, 2. Whatever. You will solve 4, 9, 2. But then you have 5 repeats. 5 repeats. How are you gonna deal with 5 repeats? I don't know. No clue. It has to be like, if we pick something and then we say, what's the total difference of this? Right? Whatever, we can figure out this. I mean, in this case, we have 10, whatever. So we have 1, and I say have 2 repeats. No, I have 5 repeats. No 1, right? We can say we have 1, 1. Okay. 1, 1. Can be 2, so 1, 1 will be here, right? Then we can say, if I have 1, 1, then can we say this remaining is some stuff? We cannot, because we have these 2. These 2 has to be unique, right? So now we have 3. Then we have 2 left, right? These will have whatever. Then we have 2 left. So let's say we have a lot left, right? We have a lot left. We can calculate the total of here. Then we have a lot left. But then how do we deal with the 2 here? Yeah, I don't know. I give up. DP. Oh, yeah, so simple. What the hell? It's very simple. Look at this. It's very simple. The hell? So it's a simple DP. I can't figure it out. No, we cannot. It's only 2 level DP. of length I containing exactly j unique songs. Our goal is to compute go with n unique songs. That is true because the k will remain the same. The k will remain the same. The k will remain the same, so you don't have to worry about the k. Okay. What's the transition? If we add a song that haven't been played yet to the playlist length increase by 1, and the number of unique songs also increase by 1. Therefore, a playlist of length I, changing songs can be formed by adding a new song to each play. Yeah, we get that. We get that. That's what we have. We have that. Wait, hold on. If we add a song, I'm do it one more time. We haven't played yet. The playlist length increased by 1. Okay? And the number of unique songs also increased by 1. Yeah. So we add a unique song, so the total number should be this. -1, -1. Can be formed by adding new songs to each playlist of length this unique songs. Yes. We have j-1 unique songs in the playlist. Since there are n unique songs in total, the total number of new songs that we can add is this. Yeah, so for each new song we add, we're gonna do this times. I understand that. I think isn't this what you're trying to do already? Oh, not exactly, but close. So what we want to find out, hold on, what it's trying to say is, if I say dpij is the number of playlists with I length and j unique songs, right? With I length and j unique songs. So we want to find that. With I length and then j unique songs. So the solution, the one we want to find is going to be dp go and n. And to find that, we say if I have, let's say, it's different from this because this is bottom up. I think the other way. This is top down. Maybe, let's just bottom up first. So we want to find dpij, right? And what we know is if the jth song is a unique one, right? With j unique songs. So if I have I length, so I have I -1 and j -1, right? And if we want to find dpij, then we have j -1 unique songs. It doesn't matter what unique songs. It's just j -1 unique songs with I -1 length, right? Now we want to add a new unique song. New unique song. And how many new unique songs we have is n minus j plus 1 unique songs. So for each new unique song we add, right, we can multiply by this. That makes sense, right? That's if I add a unique song. Okay? What if I don't add a unique song? What if I want to add a repeated song? Repeated song. So I have whatever this length with j minus 1 unique songs. And I want to add a new song that is not this, but it is a song that's been played before. Then we know we can pick K. So one song here, we can pick that song, right? Wait, hold on. We have this many playlists, right? Now for each playlist, I can repeat this. Every single one I can repeat. If I want to pick a repeated song. So you're telling me it's going to be dpi minus 1, j minus 1. We have that many combinations already, playlists already. And for each playlist, right, I can multiply it by dpi minus 1, j minus 1. No, it's not. That's the total number. So we don't need a total number. What we need is the length, right? J minus 1. Now that's a unique number of songs. That's unique number of songs. But I can pick because this doesn't never repeats. So I can choose this one to repeat. Right? I can choose this one, the first available to repeat. I can repeat that. But I cannot repeat this one. Not always, because it depends on whether this one is already repeated here. Right? If this one is already repeated here, then we cannot pick this one again, but we can repeat this one. So for each one, I can extend 1. So we have that much. Yeah, this is what I got stuck. If we replay an old song, the playlist increased by, but the number of unique songs is still J. Yes. The number of playlists length I and the J unique songs can be increased by replaying an old song in every playlist with length I minus 1 with J unique songs. Oh, what's that way of thinking? If we replay an old song, holy crap, that is correct. If we play an old song, that means we're doing I minus I with j minus 1 unique songs. Length I, but with j minus 1 unique songs. How many previously? We can play length is I, and then I want j minus 1. unique songs. Unique songs. How many previous played songs can we? We have J unique played song. J unique songs in the playlist. Wait. Hold on. No. That's not right. That's not right. Now we want to play. What we want to find out is this. Okay? That's what we want to find out. So if we repeat a song, that means it's because it has to be J unique songs filling into I positions, right? Filling into I positions. Now I say if one song needs to be repeated, then whichever song gets repeated, right? That means we shall have I minus 1 number of songs. We fill in J unique songs to it, and the last song is going to be the repeated song, right? Last song is going to be the repeated song, and the last song is going to be repeated. And how many songs can be repeated? Exactly, how many songs can be repeated? Yeah, we have a state is J unique songs with I minus 1. Right, we have all of them. Okay, all different combinations. And now I want, because we have J unique songs already in it. Right, we have J unique songs inside this I minus 1. We have J unique songs inside this I minus 1 range, and then I need to say I want to play one more song. Okay, I already have J unique, then I want a new one, right? I want a new one, not a new one, the one that we played before, and I have all different types, right? All of them. We have all of them. Yeah, my thinking is always for each how many different we can find, but it's, it depends on K. It's very difficult to say, right? It's very difficult to say. If you are asking me, right? You're asking me like among those K, because I cannot choose anything inside those K, right? I cannot choose any song inside those K songs. And those K songs must all be unique. Right? Those K songs must all be unique. So we have K unique songs. These are the K unique songs. And the new songs cannot be one of the K unique songs. So are you telling me there's gonna times with J unique songs minus those K, we can pick anything else? I think this is correct. At least we got one of them correct. It's not difficult. I don't know why. It just, didn't click today again. I think it's because the DP situation I was thinking about was not correct initially. Right? Because I was thinking N with a goal, right? That's what I was thinking. N with a goal. And I thought K is part of it. That's the first error. K should not be considered as part of the state. And then I was thinking, okay, we have 3 songs. And then we have 2 songs. Okay, limit 1, 2 songs. But what I should be thinking about is n unique songs with length, with goal length. Okay? So in this case, I already find out the situation is going to be, we say dpij, right, shall equal to, if the jth song has not been heard before, that is going to be dpi minus 1, j minus 1, times how many more unique songs we have, n minus j plus 1, plus, if we want to repeat, then that's going to be I minus 1j. And what can we repeat? Because those k songs cannot be repeated. So the number of songs that we can repeat is going to be j minus k. Of course, j has to be larger than k. Right? So we do that, which is the new one. Which means on a dpij, if you think about a 2D, a dpij is here. Depends on this I minus 1, j minus 1, and dpi minus 1 depends on these two. Right, so this one requires this and this. So we can do like 2 layers. It'll be very easy to handle. In this case, maybe we can go right to left. Right, if I fill out 1 row, and then for this, use this and this, and I fill it up. Because everyone will use the 1 itself and to left, so I can go right to left. So what's the initial condition? Right, the top row, the first row. And k is 0. Yeah, what's the edge case situation? So like this is I, this is j. I is the length. So if I is equal to 0, which means everything should be 0, so the first row should all be 0, right? And then I have dp1. I don't know. dp1 with a maximum, right? Maximum j. dp1j. So I say dp1j shall equal to dp 0 j minus 1. That's a 0, right? And this is a 0 as well. So that's definitely not right. So maybe the first row should be dp1, right? That should be the first row. And if it's dp1, which means we only have length is 1. So the first row length is 1, right? We have length is 1. And we have, we start from, let's say, 0. 0 numbers, that's a 0. If I have 1 number, that's 1. 2 numbers, then we can fit 2, right? 3, 4, 5, right? Now on the second row, what we can do for this position, right? For this position, it's dp2 with 5. Right? 2 is 5. 2 with 5 shall equal to dp 1 with 4 times n is 5. 5 minus 5 plus 1 is 1. So this times 1 because I want to have 1 additional plus dp I minus 1 is 1, right? 1 5 times j is 5. So how many we can move? So let's say k equals 1. So we're doing 2 5 1. So that times 1. So this is 5. No, 1 4 is 4. 4 plus 5. 9? 251 is not 9. 251 is 2. Right? 251 is 2. Oh, it's not right. I think this is wrong. Once we have 1, right? With 5 unique. What am I going to do? If we have... Oh, that's not right. That's not right. This is J's number of unique. This is 5 unique. Your n become 5. Go become 1. Nah. My bad. This is not right. 251 is not this. It's this should be 5. Right? This should only be 2. It should only be 2. That should only be 2. Right? Because we have 2 uniques with 1. So, that's it. Because go has to be larger than... Yeah, go. How about 2? 2, 2, 1. We can do 2, 3, 1, right? 2, 2. Okay, what's this one? So we're going to find dp 2, 2. Right, 2 lengths with 2 uniques. So it's going to be this 2 times 1 plus no, that's 1. Right? 1 times n is 2. 2 minus 2 is times 1, so it's 1. We add a new. Alright. So I have 1 unique. 1 unique with 1 is going to be 1. And we want to add another unique. Right? I want to add another unique. How many more unique we have? We have only 1 more unique. So that's 1. Then we'll plus 1, 2. And j is 2. 2 minus 1 is 1. So 1 plus 2. That becomes 3? This becomes 3? No, it's not 3. 2, 2, 1 shall be 2. Still not right. Yeah, it's supposed to be 2. What the hell? For one unique with one length, that's just one. Two uniques with the length is one. Oh, two uniques with the length is one is not allowed. Two uniques with the length is one is not allowed. Two uniques with the length is one is not allowed. I is goal. Goal is 1 to goal. And then J is 1 to minimum I, yes, so we don't go beyond. So if you do DP22, you need to do DP11 and DP12. How'd you handle DP12? Goal is 1 with 2 unique songs. I don't know, how'd you do that? They say we set the first to 0. No, first to 1. So I equal to 1. This is 0, 1, 2, 3, 4, 5. So if this is 1, that should be 1 because I say this is diagonal and this times n. If n equal to 2, okay, j is 1, so we have 2. So we have 2 Huh? N is 2. J is 1. 2 minus 1. 1 minus 1 is 2. 2. 2. One unique song can be different songs. One unique song, it can be different songs. All it needs is just to be one unique. It doesn't matter which unique songs. Actually, these values we don't even fill, right? These values we don't even fill. It's just gonna be 2. It's under the current condition, right? Given 2 songs in total. If I have one unique song to fill one spot, what is the total number? Of course, you can do one song, you can do the other song. I think that's what I also got wrong. What I got wrong in so many different places. And that's it, right? Because I equal to 1, J at most can get to 1. J cannot be more. So if I equal to 2, we all start from I equal to 2. So I can do 2. No, I think I can do 1, 2 here. Wait, can I do 1, 2? If n equal to 2, I is 1. That's it. Now I equal to 2. So J can be 1. Yes, J can be 1. Or J can be 2. And now we can do this. It can be J can be 1, 2, 3. And we started going. Okay, so for J equal to 1, so we're doing 2, 1, right? So what's the diagonal? So everybody else is 0. These are 0. Because you cannot do one position with 2 unique songs. Yeah, because the number of unique songs must be smaller or equal to, it says, the number of unique songs must be smaller or equal to the total length. The number, I don't know what just troubles me so much. The number of unique songs. One unique song. Total number of songs is 2 songs. Total we have 2 unique songs. But I can, among the 2 unique songs, choose 1 unique song to fit in 1 spot. I cannot choose 2 unique songs to fit in 1 spot. That's invalid. So everybody else is 0. Everybody else is 0. So now for this position, yes, you can do this and this, you get a value. And for this position, you can do this and this, get a value. And then we can now go more. We can now go even more. I don't know, man. It feels so easy, right, when you look at the solution. Number of unique sounds. We can code this one for sure. But I'm very, very unhappy. Pissed. Such an easy problem and it wasn't able to solve at all. n+1. Right? And then dp0 equal to 0 equal to 1. Given 0 unique sounds, we have one way to fit a playlist of length 0. dpij is the number of way to fit j unique songs from n total songs. And that's the one kind of troubles me the most. Is j unique songs from the total number of songs we pick j, right? Fit any j unique songs into a playlist of length I. I think that is what I need. And this is given, right? Then we can say for I in range 1 to go, right? Then for each one, dpij can be computed in 2 ways. And a temp is equal to 0 times n minus n+1. And temp 0 equal to 1. Can we compute it in 2 ways, right? First, the jth song added is a new song, right? Then for each new song added, we have dpi minus 1, j minus 1 number of ways. And there are n minus j plus 1, right? Number of new songs at the moment. Because we used j minus 1 unique songs. So the jth song is a new song. So we have that many new songs to choose from, right? So we used j minus 1 unique songs, right? So j minus 1 unique songs is gone. And we have n minus j plus 1 songs. So each one of them, we have that many. Thus, this way adds dp I minus 1, j minus 1 times n minus 1, n minus j plus 1 number of ways. Second, the jth song is a repeated song, right? Then it's a repeated song. Then we have already, right? Then we need to look at dpi minus 1 j, right? I minus 1. Then for each allowed repeated song, for each allowed repeated song, if I use that, whatever this song is allowed, then we have this many, right? We have this many ways of creating, of generating a playlist. We have this many ways to generate a playlist, right? Given that the jth song is a repeated song, right? The jth song is a repeated song. If it's repeated, that means we already have j unique songs, right? So we're going to find j unique songs to fit into a length of I, but if those j songs, if the j song is unique, that means, yeah, this is the difficult part. We have j songs, right? So we have j songs can fit into I minus 1. J songs fit into I minus 1. Then we add a new song. Because we have I minus 1, exactly. I minus 1 is the number of songs in the playlist, right? So that's what we have. Now we add a new song. But the new song is already chosen. It's already in the I minus 1. So the total ways is I minus 1j, yes. So the j unique songs to fit in I minus 1. Now the new song is unique, so we need to find out which song can we repeat, right? Now, how many songs are we allowed to repeat, right? Since we must repeat with a gap, with a gap of k, that means we cannot repeat any of the last k songs, right? Last k songs in. We cannot repeat any of the last k songs, right? Cannot repeat any of the last k songs. We cannot repeat any of the last k songs. And those k songs are all unique. Thus, the songs allowed to repeat is j minus k. J minus k. So we can say dp, right, for j in range, which we can do one song all the way to minimum in plus 1. Yeah, because I cannot go beyond the goal. N cannot go beyond the goal. Right, we can say temp j shall equal to dp j minus 1 times n minus j plus 1 mod, right? And if j is larger than k, temp j, well, plus equal to dp j times j minus k mod. Once we're done, we say dp equal to temp. Once we're done, we return dp minus 1. Man, DP is so... so hard. It is not right. What the hell? I don't know. What the hell? I think starting from, I think this probably is the problem. We shouldn't do this. There we go. Because starting from the second, you don't have it. You don't have the first one is 1. I failed big time. Three hours. Not able to solve. And the solution is actually pretty simple. But I simply could not wrap my head around the DP conditions, DP state. Yeah, this is, the DP state is just so hard for me to wrap around. The number of unique songs within the given songs, right? Within the given songs, with all different combinations. I think I want to revisit this problem tomorrow. And do I'll revisit this tomorrow and do a top down. You're kidding me. Seriously? Alright, we have to end here. It's very late. And yeah, I need to do a top down. Basically come back to this tomorrow and then think about it again. And try to think how to do a top down. Alright, I'll see you guys tomorrow. Adios.